Hey all, I warmly welcome you to Wanies Academy. All right, so we are having a new topic today in chemistry class. So that topic is calculating mass in reactions. So the aim for this class is to explain how masses of substances can be calculated in reactions. Then the objectives are as follows. At the end of the class, the student should be able to, one, deduce the relationship between mass and other parameters in an equation. Two, use coefficient of balance equations to deduce masses. Then three, carry out calculations involving masses in reactions. So these are the objectives outlined for this class. So I want to give you the step-by-step guide on how to determine or how to calculate masses of substances in given reactions in chemistry. So now the first step is to write a balanced chemical equation of the reaction that you are given. Then the second step is to calculate the formula masses, the relative formula masses of the substances, which can be the relative molecular mass or the molar mass of the substance. Then the third step that you are supposed to carry out is you have to use the equation as a ratio. So that means underneath the balanced equation that you have written in step one, you have to write the calculated relative formula mass of each of the substances represented in the equation, ensuring that the equation is correctly balanced. Then the fourth step is to set up what we call a proportionality limit, right? So the fourth step is for you to set up what we call a proportionality limit. Now this entails that you establish the proportion between the known substance mass and its calculated total relative molecular mass and the unknown substance mass. So that means the mass of the known and the mass of the unknown is established based on the equation that is written. So to illustrate this step, I have a question I would like us to solve. Now the question goes to us. Now, magnesium undergoes combustion to produce magnesium oxide. Calculate the mass of magnesium oxide that can be completely burned. Calculate the mass of magnesium oxide that can be made by completely burning 6.0 gram of magnesium in oxygen. So now the first thing is to write a balanced chemical equation. Now this reaction involves combustion or burning between magnesium and oxygen because the gas that we use for burning is oxygen gas. So the equation of reaction goes to us. So we have magnesium, which exists as a solid. So magnesium undergoing combustion in the presence of oxygen gas. So we have Mg plus O2, right? Oxygen gas. So the product of this reaction is magnesium oxide. So magnesium oxide is produced, which is a basic oxide or a metallic oxide. So that is MgO is produced as a product for this reaction. So we have our MgO here. So MgO, magnesium oxide. All right. So oxygen is 2 here, oxygen is 1 here. Therefore, we have to balance this equation by adding the coefficient 2 behind the magnesium oxide. So magnesium is now 1 here and it's 2 on the right side of the equation. So we add the 2 here. So there goes the first step. You write a balanced chemical equation. Now, the substances we have business with based on the question asked are magnesium and magnesium oxide. So from this equation, you can see that 2 moles of magnesium will give us 2 moles of magnesium oxide. So the number of moles for the two substances, they are the same on both sides of the equation. So 2 moles of magnesium, 2 moles of magnesium oxide. Now, however, we are given 6.0 gram of magnesium in 6.0 gram of magnesium in oxygen. Therefore, convert that 6.0 gram of magnesium to mole. So the formula is mole equals to mass over molar mass. So small m, so the small m representing your mass. So mole equals to mass over molar mass, right? So now to do that, we have that your mole equals to the mass of the magnesium, which is 6, to be divided by the relative atomic mass, which represents the molar mass. So that means 6 divided by 24. The 24 being the molar mass of magnesium. So that will give us 0.25 mole. So 6 divided by 24 gives 0.25 mole of magnesium. So that is 0.25 mole of magnesium. All right, so we have all our parameters now in mole. All the substances now, they are expressed in mole. So remember that the coefficient of a balanced equation represents number of moles. So the coefficient 2 here represents number of moles. So now having established that we have 2 moles for magnesium and 2 moles for magnesium oxide, and now just converted the 6 gram to 0.25. So now let me erase the board so you can have that relationship clearly stated on the board. All right, so here we go. So we have, based on the equation, 2 moles of magnesium, 2 moles of magnesium. Based on the equation written, the balanced equation, so 2 moles of magnesium will give us 2 moles of magnesium oxide as well. So 2 moles of magnesium equals to 2 moles of MgO as well, based on the equation that is written, as you can see here. Then we just got 0.25 mole. So the question is, how many mole will this 0.25 mole give you? So 0.25 mole of magnesium. So 0.25 mole of magnesium. So give us how many moles of magnesium oxide. So 0.25 mole of magnesium. So how many moles of magnesium oxide would that give us? So that is unknown, right? So you can put that as X, unknown mole of magnesium that is produced by 0.25 moles of magnesium. So you can cross multiply this equation. So you can see here that X times 2 will definitely give us a 2X. So X times 2 gives 2X, right? Then 0.25 times 2 will give us 0.5. So 0.25 times 2 will produce or give us 0.5. So 0.5. So you have to divide both sides by 2, right? I'm dividing both sides by 2. So now let's erase the board to create additional space. So now means our X, which represents the number of mole of magnesium oxide that were produced from 0.25 mole. So now that will give us 0.25 mole again. So as you can see, so X equals to 0.5 divided by 2. So that means your X here will give us 0.25 moles. So X equals to 0.25 moles of MgO, of magnesium oxide. So that will give you 0.25 moles again. So you have gotten the number of mole of magnesium oxide that is produced by 6 gram of magnesium. So this is 0.25 mole of magnesium oxide, that is MgO. However, it's mass we need. So you have to convert this 0.25 mole to mass. So using the same formula. So now let's erase this board, create additional space. So now remember that your equation is N equals to mass over molar mass, meaning mole equals to mass over molar mass. So you have to make mass the subject of formula. So by the time you do that, you have that your mass equals to, so using the fact that your mole equals to mass over molar mass. So using mole equals to mass over molar mass, right? So it's mass we are looking for. So make mass the subject of formula. So we have small m mass. This is your mass, small m mass, equals to your mole of magnesium oxide. That's 0.25 mole. So 0.25 mole. So 0.25 mole of magnesium oxide times the molar mass of magnesium oxide, right? So magnesium oxide, so you have to calculate the molar mass of magnesium oxide. So that is, magnesium is 24, then the oxygen is 16. So that means you are saying 24 plus 16, since you have one atom of each. So 24 plus 16 should give you 40. So you can see. So 24 plus 16 will normally give you 40. So you see here. So our mass equals to 0.25 times 40. So 0.25 times 40, that should give you 10 grams. So the answer there is 10 grams. So 0.25 times 40. So 0.25 will give you 10 grams. So 10 grams of magnesium are produced from 6 grams. 10 grams of magnesium oxide are produced from 6 grams of magnesium. So the answer is 10 grams, as you can see here. All right. 10 grams of magnesium. So with that, we have come to the end of today's class. Thanks for watching. So please remember to click on the subscribe button and also remember to share this with family and friends.